Hi there! In this video, we're going to talk about how to graph compound inequalities. So why is this something that I need to know? Well, it helps me both understand and visualize or just see what the solutions are or how many solutions there are when I'm dealing with multiple inequalities. So what are compound inequalities? I think I need to know that first before I can kind of dive in a little bit deeper in this lesson. So basically, compound inequalities are when I have two inequalities that I join together. So when I say an inequality, I mean something like x is greater than or equal to 2, something like that. An inequality that I join with another inequality, and I connect them with either the connecting word and, or I use the connecting word or. And the type of connecting word that you have depends on, well, it means something different. So let's talk about what it means, what I'm looking for when my inequalities are connected with the word and. So when I make my graph, both of the lines of my solutions must overlap. They have to happen at the same time because the inequality has to be true at the same time in both situations, in both inequalities, for it to be and. You want to think of and like if I had a cup that I flipped upside down where I trapped all my things that were the same, you have to trap all the solutions that are the same at the same time. That's what's going to give you your and. So typically, this means that my graph, I like to call it sandwiched. I like to call these sandwich graphs. Very mathematical, I know, but I call them sandwich graphs. So my answers are sandwiched in between two numbers. And the graphs typically look like this. So I'm going to show you. When I graph two inequalities, by the way, this green inequality says that x is less than or equal to 22, and this pink inequality says that x is greater than 10. Okay, so when I'm graphing these inequalities, I want to see, do you see where both the lines are happening at the same time? You're looking between 10 and 22. So to find out what my answer is, I have to use the kind of circle that's on my endpoint. So this pink one, I'm starting at 10. So I'm going to have an open circle on the 10, and I'm ending at 22. That's where they overlap, the overlap ends, but this one has a closed circle. And then I literally just connect them in between. So my graph, my final answer, actually, I get rid of this stuff, and I only am looking at this blue graph so that you can kind of see. Do you see what I mean by sandwich? So here's one, here's the other, and then all the answers are in between. That's what I mean by sandwiched in the middle. And a lot of times they'll write the inequality. They might say like between 10 and 22, like the x will be sandwiched in the middle also. That's also another clue that you're dealing with an and connecting word or an and compound inequality. Okay, the other connecting word is or. Now, or happens literally anytime you have a solution, anytime you have a line anywhere, because or means, well, it could be this one or it could be this one. It doesn't have to be both at the same time like and. It could literally be one or the other. So on a graph, when you're looking at it, it's wherever the line goes. Sometimes the lines are going to overlap, and that's okay because it can be one or the other. Typically, the or graph, I like to call them like the shooting out kind of graphs. Like if you like hold together your hands, palms facing you, and you make some fists and you point your thumbs out, like one's pointing to the right and one's pointing to the left, they're shooting out towards the ends. I know I wrote ends in quotation because there's really no end to like a line like this, but it's shooting out towards the ends, not going towards each other. They're going away from each other. That's typically what an or graph is going to look like. So I have one written here for you, and if you were to read this, this would say that x is less than or equal to 14, or x is greater than 24. That's what's graphed right here. Okay, so how did I know, though, to use an open versus a closed dot? So you'll notice on this example up here that my dot is a closed dot and this one's an open dot. So how did I know in my graph whether to use an open or closed dot? you actually know by the kind of inequality that is given in your problem. So if you have something that is greater than or less than, you're going to use an open dot. We use an open dot to indicate that the starting point is not included. Because remember, if I had something like x is greater than 10, that means the number has to be bigger than 10. 10's not part of my answer, but 10.01 would be because it's bigger than 10, but I cannot include 10. So I'm going to use a closed dot if it was x is greater than or equal to 10. Then I would use a closed dot to indicate, well, I can include 10 in part of my answer and everything else that's bigger than it. So I think the closed helps to remind you that this one is included, where open says, well, I'm starting here, but I'm not including that point. So we're going to do two examples, one of an OR graph and one of an AND graph. Okay, so the first one I'm going to graph, this says x is greater than or equal to 5 or x is less than -1. So I'm going to graph the one on the left first. X is greater than or equal to 5. So that means I'm going to go over to 5 on my number line. And I like to draw my graphs above my number line, not on it. Some people will draw it on it like this. I think it's easier if you draw it above because then you can see your lines better and see your dots better. So x is greater than or equal to means I'm going to use a closed circle. Greater than or equal to means bigger than, so I want all numbers bigger than 5. I'm going to go shade to the right. Now here's a trick. In my inequality, see how my variable is on the left-hand side of my inequality. Like if this is my inequality, this is my left and this is my right. When my variable is on the left-hand side of my inequality, I can use my inequality as an arrow to make sure I shaded in the correct direction. If I put a line here like this, it tells me my arrow is going to the right, and I look down and I say, oh, look, my arrow is going to the right. It only works when the x or the variable is on the left-hand side. Okay, the next one says x is less than -1. All right, so I have to go over to -1. Now, it just says less than, so that means it's an open circle because I don't have an equals to underneath it. Less than means smaller than, and all numbers smaller are on the left-hand side of my number line, so I'm going to go in this way, drawing my line. And remember, you could check, if I zoom this in, my variable's on the left, so I can use this trick to say, yeah, my arrow is actually going to point to the left. So that would be my graph. Okay, and the last one. I want to graph x is less than 8 and x is greater than or equal to 5. Okay, now another way that you might see this written without the connecting word and is they'll write the smallest number on the left-hand side, the biggest number on the right-hand side, and connect them with they're going to be both less than symbols because smallest is going to be on the left and biggest is going to be on the right. And I'm putting a less than or equal to here because it has an equal to here. So you might see it written this way also. That means that the connecting word for your inequalities is and, because if you look at it, you can see there's this inequality, okay? And then there's also this inequality. So we kind of smush them together, which is another reason why I call this sandwich inequalities. All right, so I'm going to graph what I have on the top, and then we're going to talk about this orange one on the bottom, this orange highlighted part in just a second. So if I graph what I have on the top, I have x is less than 8. So I'm going to graph, I go to my 8, I'm going to put an open circle because it's just less than. Less than means smaller than, and smaller than is to the left-hand side. So there's that part. And x is greater than or equal to 5. So greater than or equal to is going to be a closed dot. Greater than means bigger, and bigger is to the right, this way. And because this is an and graph, I want to look where, let me pick a different color here. Green. Where are they overlapping? Where are they touching? Here. So my final answer, I would start closed circle at 5, open circle at 8, and go in between. So I wouldn't need all of this written. I just want the blue part. Now it's handy when they write it in this method here because then I don't have to do each individual graph and then see where they overlap, I know that this means I'm going to have a sandwich graph. The last thing I wanted to talk about is when I read an inequality when the variable's on the right. When you read it like this, you start from the right. This is one of the only times that you ever read from right to left. I start on the right and I read to the left. So this says x is greater than or equal to 5. When you read it that way, it's like the sign also flips because you're reading the sign this way. So this actually means the same thing as that. It's just written the other way with the variable on the other side. So, and the nice part about doing that is then you'll be able to use that trick that I told you about, oh, well, that means that my arrow is actually going to go to the right. Because when the variable's on the left, that trick doesn't work. Okay, if you have any questions, let me know. Remember, and is the sandwich graph and or is the graph that shoots out towards the end. Good luck.